eventually it became apparent that we just can't use open communication all the time. We need some sort of privacy when we're on our wireless networks. And so what we first attempted was something called wired equivalent privacy. Now, the idea was to make wireless as private as wired. And it didn't really achieve it. As a matter of fact, it's pretty weak. Sometimes I would call it worst ever privacy, because that's about what it is, about the worst ever. It uses a key for authentication, but you do not provide that key. Unlike with WPA that we'll talk about later in WPA2, I can choose a password, if you wish, or a key for authentication. But when you set up WEP, it just gives you a set of numbers and symbols that you have to put in on your computer in order to reach it. This is generated by the wireless router itself. It uses a 40-bit RC4 encryption. Now, if you remember back to our discussion on encryption, you might remember that RC4 is a streaming encryption method. It's not particularly powerful, but that is not the biggest weakness in the system. The real weakness that makes this so bad is this, the 24-bit initialization vector. Now what this is a number that changes with every frame. Now this part, the 40-bit encryption key that is used for RC4, stays the same. But the 24-bit initialization vector changes with every frame. It's concatenated with the 40-bit encryption key. So you've got a number, and then attached to it or concatenated to it is the encryption key, which is that series of letters and numbers that this thing generated for you. This IV is not only appended, but it is sent in clear text. So in other words, while this 40-bit encryption key is encrypted when it's sent across the airwaves, this 24-bit initialization vector is not. It is sent in clear text. It also, being only 24 bits, means after a few thousand times, it's going to have to be reused. And so this frequent reuse of IVs is what makes this thing so weak. And I'm not really going to go into, I might provide you a video, but I'm not really going to go into the whole cracking routine. I'll give you a real brief overview though. Essentially, it involves, first of all, kicking somebody off of their network. And that is done with a deauthorization tool or with a Wi-Fi access card that can do it, and not everyone can. You deauthorize the person, and then as they log back on, you capture that handshake. But that's not all you capture. You also capture the set of frames used to attempt to log on. And then you replay that over and over and over again. And it keeps this thing busy. It keeps it doing lots of work and sending lots of data back and forth between the person that you're trying to hack and their access point. So during that time, you're collecting these IVs. Once you collect enough of them, and it usually only takes maybe 3 minutes or so to do, once you collect enough of these IVs and they start to repeat with themselves, then you can do some math to reverse engineer the encryption key and figure out what that encryption key is, and then you can get on the system.